So hello everyone, on behalf of PHRN, welcome to the Linkage Luminaries webinar series for 2022. My name is Merryn Smith and I'm Chief Executive at the PHRN. I'd like to begin by acknowledging the traditional custodians of all the lands that we're meeting on today and paying my respects to elders past and present. First, some housekeeping. If you have any questions for today's speaker, please type them in the Q&A box at any time during the presentation. We'll answer as many as possible during the after presentation. So I'm really delighted today to introduce Professor Louisa Jorm as today's presenter. Professor Jorm is a professor at the Faculty of Medicine and Health at the University of New South Wales. She's also a Foundation Director of the Centre for Big Data Research in Health at UNSW. Professor Jorm has worked in senior leadership roles in both government and academia, giving her unique insights and opportunities for translational research impacts. She's an international leader in health big data research, specifically in applying advanced analytic methods to large-scale, routinely collected data, including hospital and medical and pharmaceutical claims data. Her main current research interests are in the application of advanced analytics to large-scale electronic health data to create real-world evidence about topics including cardiovascular risk prediction, disparities in disease care and outcomes, variation in surgical outcomes, and healthcare at the end of life. Linked data is a valuable tool for all of these topics, so I'm looking forward to hearing more about how Professor Jorm has used linked data in her research. So over to you, Louisa.
Thanks so much, Merryn. I'll just share my screen. Here we go. And put that into presentation mode. Is that now in presentation mode for everyone? Yep. So again, thanks so much, Merryn, and thanks to the PHRN for inviting me and for everyone who's attending today. I can't see you, but I believe there was quite a large number of people who registered, so I'm delighted to be with you today. And I'd also like to acknowledge the traditional owners of the land on which I'm joining you from, which are the Bedjigal people, and pay my respects to their elders past and present. So, I was sort of given free rein in terms of what my talk today would be about. Lately, I've been thinking a lot about how to actually ensure that research that I do actually is implemented in some way to either change policy or change clinical practice. And once implemented, actually does have some sort of impact. And I think a lot of us will recognise that there's quite a lot of challenges in having impact when your work is data linkage research. And also there's a long time frame often between the research being done and then the impacts being evident. And it's not necessarily all that easy to capture those impacts. Why, is impact important? There's reasons like this that we're basically expected to be accountable and to generate value for money for the research funds that we are awarded, in particular when the work's funded from the public purse, which a lot of it is. And funders also increasingly are need to demonstrate the benefits to government from their research spending. And there's a whole movement also to try to reduce waste in research that recognises that a lot of the research that is done is not very high quality, is duplicative, and in fact does not have any impacts beyond the purely academic ones of gathering citations. So these are all good reasons that impact is important, but I think probably something that drives all of us who are doing research is we actually want to have an impact as well. It's why we're doing it. We're not doing it for just trying to demonstrate value for money. We are actually trying to improve health services, and in general have a societal good from the work that we're doing. So I think it's something that the funders and everyone else is requiring us to think about a lot more. And I think data linkage researchers do have some difficulties, as I said, in trying to generate impact. And I know that having been on many grant review panels, chaired NHMRC panels and MRFF panels recently, there's often a view expressed by people from other fields of research that this is just purely descriptive research. It's sort of retrospective, so things have already happened and you're sort of demonstrating things that have happened, but that you're not necessarily going to be driving change through this research. And so that is actually a challenge for us. And I guess that's what I'm trying to focus on today, is some ways that we can try to improve and increase the impact of data linkage research. Probably all of you will have seen the Australian Medical Research and Innovation Strategy, which is the strategy that sits behind the MRFF. I'm not going to read it out, but any of you who have been involved in writing MRFF grants or have been awarded them will note that there is a very strong emphasis on research translation, and in fact you're actually asked to demonstrate that your research will have some form of impact within 12 months of the grant being completed, which actually is a quite challenging thing for us as data linkage researchers. But I think all of us can probably already have benefited from this new stream of research through the MRFF, which is funding a lot of health systems and health services research that often did struggle to receive funding through traditional NHMRC mechanisms. So just some thoughts of mine about how one can increase implementation and impact of data linkage research. I'm sorry, there's a little thing that keeps, little chat thing, I think I've turned that off now, that kept making a dinging sound, sorry about that. And there's three areas that I wanted to focus on. One is making sure that we're addressing questions that matter. And I think a key way of doing that is through partnership and commissioned research, rather than solely investigator-driven approaches. The second, I think, is linking in novel data sets. And I think increasingly the days are gone where projects that just purely use readily available administrative data sets and link those together are actually viewed as being particularly novel or as moving beyond sort of descriptive type approaches, and they do struggle to get funded. It's really, I think, the future in data linkage is actually linking in these extra sources that add additional information, whether that be survey-based information about health risk factors or demographics, whether it be detailed clinical information from a range of systems that are coming available, for example, electronic medical records, whether these be hospital or primary care based, or also more detailed service information, so you can actually use data linkage to evaluate programs and services. Often there is only very limited information available in administrative data about services. And then the third area is trying to integrate novel analytics. Everyone is aware of the fact that there's a sort of an AI that can be applied to anything these days. But any of you who have worked with people who come from backgrounds in computer science, for example, will recognise there's actually quite a big chasm, methodological chasm between their world and ours. And I've done a literature review actually looking at the implementation of machine learning and AI algorithms in actual real world healthcare or health policy. And there's hardly any actual implementation. There is a big implementation gap. And a lot of that relates to academics in the machine learning field having a very a fixation on getting the best model fit. And indeed, an approach that's commonly used in that field, which probably we should be using more of in our field, is running competitions where they provide a data set, they pose a problem, and they then see who can build the best algorithm. But they come down to very small differences in the area under the curve as being the thing that they're interested in, rather than how could one actually implement this algorithm in a real world setting, which is a very, very complex setting in healthcare. And I think that's why there has been little implementation. And also the black box nature of many of these analytics mean that their safety and effectiveness is hard to determine. And it's not surprising that in a potentially high risk environment such as healthcare, people are not very willing to implement something that they do not understand and cannot really explain what the model predictions mean or where they come from. So those are the three areas I'm going to focus on a little bit more today. Okay. So in terms of addressing questions that matter, I'm going to sort of today just talk about a range of projects that I've worked on over the years that I guess have had impact in various ways, or just demonstrate those three mechanisms or pathways for trying to improve impact that I just talked about. And this is a project that's, some years old now, but it's an example of what was basically a commissioned research project. So this was not funded through a grant. We were in fact approached by Health Direct. Many of you will be familiar with Health Direct, which is a telephone triage service that operates across multiple state and territory jurisdictions. Increasingly, things like Health Direct in the days of COVID have become really important. But the underlying idea behind this system and other similar ones internationally is that people can call a helpline, can speak to, work through a protocol with a nurse on the other end of the phone, who then gives them what's called a disposition, so a recommendation about what they should do, whether they should immediately go to the emergency department, whether they should book themselves into a GP, whether they should just wait and see. And the idea behind these lines obviously is to provide a readily accessible and low cost mechanism for people to access care and to get hopefully appropriate advice, and eventually to, for example, decrease the pressure on emergency departments. And so this project was about actually trying to see whether or not individuals who were given advice by the Health Direct helpline actually followed that advice. And there was no way of doing that other than through data linkage. And so what we did was gain access to Health Direct helpline call information, which is all recorded electronically. We had a lot of calls. We had more than 1.2 million calls in the study for more than 700,000 patients. And then we went through the process that I think most of us are pretty familiar with, of having these call data linked with data that were part of the Centre for Health Record Linkage in New South Wales master linkage key. And this is the sort of diagram that most data linkage studies have, where you go through a process of determining who is eligible or not eligible to be included in the study. And what we ended up with was just over 1 million calls that were linked to administrative data so that we could use that to follow up. And I'm not going to go into all of the results. There's several published papers from this study, but one of the main things we looked at was where people were given advice to attend emergency department immediately. Did they attend? That's sort of the main sort of outcomes of the call service. And then we could also look at, of those, what are the predictors of actually attending ED when you're advised to. And again, this is only just a summary of some of the information. But interestingly enough, so you see a forest plot there that basically presents odds ratios for your odds of attending the ED when told to. And interestingly, key predictors of whether or not you did follow the advice was what you were already intending to do. So if your original intention, which they ask as part of the call process, was to attend ED, you're much more likely to than if your original intention was to do something else. But also, I guess not surprisingly, remoteness was a very big driver. Those who were in more remote areas were less likely to attend. And also we discovered a phenomenon of extreme Health Direct callers who made huge numbers of calls. And which is shown down the bottom there, people who have 20 plus calls, for example, in the last month. And these people were much less likely to follow advice and probably do represent a sort of a nuisance caller element, or people who are just wanting to talk to somebody. So basically, this was the biggest study of its kind to be done internationally. It did give precise information about whether or not people were following the advice from the Healthline. But really importantly, from Health Direct's point of view, we could also look at, for those people who did attend ED, was this a whole lot of people who should not have been sent to the ED who were clogging up the emergency department? And we in fact found that those people who had been referred by Health Direct were a lot less likely than general ED attendees to receive low urgency triage. So it was suggesting that the people who were recommended to go actually were people who would potentially benefit from emergency department care. And this study did have impact. It actually resulted in a range of changes to the Health Direct algorithms and processes that people stepped through, and new processes around the people who are making multiple calls. I hadn't been aware that there was this group of people who were in fact responsible for quite a lot of calls. And it was a really worthwhile project to work on. You often think commissioned research is not the thing we're after. We want Category 1 grants. We ended up with great publications, but also we did actually directly inform changes to the service, and the service continues to this day with those changes in place. The next example I wanted to talk about was another study that we did, which was an NHMRC partnership grant. And I think these partnership grants are great. And those of you who apply for grants will probably know that they have a somewhat higher success rate than other forms of grant as well. So totally encourage you to seek funding through that mechanism. In this case, the partners were the Australian Commission on Safety and Quality in Healthcare, New South Wales Agency for Clinical Innovation, and New South Wales Bureau of Health Information. And the project focused on an indicator that you're probably quite familiar with, preventable hospitalisations, potentially preventable hospitalisations, which have been used since basically back in the 1980s in Australia and in other countries as one of the key reported indicators of the quality of primary care. And when one actually looks under the bonnet of this indicator, the only reason that it is used is basically because it uses hospital data, which are readily accessible and available in most countries, rather than data that actually directly relate to primary care. And so what we were interested in doing with APHID was to try to better unpack the relationship between primary care and these hospitalisations, and get a view from multiple different angles of whether or not these are actually potentially preventable, or what are the factors that are mainly driving them. And again, a set of data linked together. In this case, the sort of particular value add came from the 45 and up study, which provided quite detailed baseline questionnaire information about demographics, self-reported health status, and health risk factors, which, as you'll all be aware, are basically not available in the routine administrative data. And also 45 and up study provides a somewhat more streamlined mechanism for getting linkage with MBS and PBS. So these were the data sets that were part of the APHID study. And again, I'll just very quickly sort of show you some of the results. So what we were looking at was geographic variation in admission, which is the usual way that this indicator is reported. And we had measures of primary care supply. We had a range of socio-demographic factors, which weren't necessarily things that could be influenced by primary care, and then factors that were amenable to behaviour change and disease management. What did we find? I guess this was one of the headline results, which was looking at, is there any relationship between GP supply and these potentially preventable admissions? And the bottom line is that there wasn't really any relationship between GP supply and these conditions, except in the case of vaccine preventable conditions, which actually sort of makes sense. But for the other categories, chronic and acute, and chronic is by far the largest, really no particular relationship at all between GP supply and potentially preventable admissions. And this looked very similar for what we called non-preventable admissions, which was everything else other than PPH. So it's sort of suggesting that rates of hospital admissions in general are not a good indicator of how much primary care is available in an area. But more than that, we could actually look at, which conditions have more relationship with the GPs, the supply of GP services. And, in this case, we find that there's not really very much association for most of the major chronic conditions in terms of the geographic variation and its association with supply. And the only ones where there was a somewhat stronger association with supply were influenza and pneumonia and asthma, but for the big ticket items, diabetes and so on, really only a very weak relationship. But then we could look at personal factors. So in this case, this is demographics and health risk factors. And you'll find there's a much greater proportion of the variation is actually explained by these personal factors, not by GP supply, for the major chronic conditions and indeed most of the potentially preventable hospitalisation. So this was sort of the headline result from this study, was that really there was a much stronger association between personal characteristics and health status and the variation in these in this indicator than there was with something that was a more direct measure of general practice. We did some fun things as part of this study where we tried to visualise people's patterns of use of various types of services. This is not really easy to see, but this was in a facility at UNSW, which is called the Epicenter. And each of those little vertical lines actually relates to a patient, and the things you can see sort of blinking out are there the times that they've used various services. You can't see it from this photo, but you could actually, find some quite interesting patterns in this, particularly in things like use of GP services and how there were big gaps in service use that related to public holidays and Christmas and so on. But also a key finding was that there was, quite a lot of use of GP services immediately leading up to most of the preventable hospitalisations, and certainly no indication that using more GP services reduced these hospitalisations, in fact, quite the reverse. But we took it further, so we did actually seek implementation, and we were invited to write a guide to the use of the potentially preventable hospitalisation indicator in Australia by the Commission on Safety and Quality, who were one of the partners in the project. So having it as that partnership meant they were part of the project throughout, and they wanted this sort of product, which is still available through the Commission. But even more than that, it actually did lead to changes in the way it's now proposed to report the indicator. And I think this bit of work may have gone somewhat on hold as a result of COVID, but there is a discussion paper that was produced by PHRN which proposes fairly major changes to the potentially preventable hospitalisation indicator and a better indicator of general practice quality to use going forward. And sort of nicely for us, our scientific papers, our guide to use of the indicator were actually, cited throughout this new discussion paper. And here you can see this is a news release that actually said the guide that we written sort of set out what these drawbacks were and helped to result in the formulation of this new indicator. But you'll see that this, a lot of the work was published in 2015, 2016. The guide was 2017. This new indicator still has not been implemented. So there is a long lead time in these sorts of projects. So the second area I want to talk about was linking in novel data sets. And you'll see that, in fact, both of the two examples I just presented did use far more than just routinely collected administrative data, one using health direct call data and the other using the 45 and up study. But I've got lots of other examples. This is some of our more recent work. I personally have had a lot of trouble trying to publish data that address clinical topics that use only routinely collected administrative data, because you will always get comments about you do not have sufficient clinical detail for, in particular risk adjustment approaches. And again, I won't, step you through all of this, but the important thing here is that we actually linked this Australasian Vascular Audit, which is a registry, a clinical registry of vascular surgery, to routinely collected hospitalisation and death data. And that AVA register contains very detailed clinical information about both the patient and the procedure that they underwent. And this study looked at long-term outcomes following repair of abdominal aortic aneurysms and compared the open repair, which has been the traditional approach, with endovascular approaches, much less invasive approaches, which have taken over. And in surgery, this real world evidence is really important because new surgical techniques often are not the subject of very large randomized controlled trials. And often if there are trials, they don't have long-term follow-up. And there is a desire to implement, in particular, these less invasive procedures quite quickly. So it's really important that we see what actually happens out in the real world with these advances in surgical technique. And just again, very quick presentation of results. And, you know, quite interesting results. This got published in Annals of Surgery. So if you're interested in academic impact, you know, in a high impact journal that you definitely would not have got into just using administrative data alone. And basically we found that the EVA, which is the endovascular repair, the less invasive procedure, had lower mortality early on, but then it switched over and mortality became higher between 1 and 4 years and after 4 years. And so basically bottom line was that, you know, this is administrative data, this is a real world study, so it has to be confirmed by multiple, you know, other studies from other settings, but did seem to be suggesting that there was higher long-term mortality and higher rates of secondary interventions, re-interventions with the less invasive technique. So this may actually be a less durable method. And clearly, you know, this work is likely to have impact. It's only just been published because it very directly relates to choice of surgical technique, and in particular patients who may have be expected to have longer lifespans. You know, great care needs to be taken in deciding whether or not to use the open repair or the endovascular procedure. And here another example of where we've actually linked in clinical registry data, and this is a large project. Listed out the collaborators there. In particular, would like to thank Catherine Dusniski for this, because these are slides that she actually prepared, setting out this project, which again NHMRC funded. This was a project grant. We never even got the data within the duration of the project grant, which is something that would not surprise any of us, I think, because this is a very ambitious project that sought to do, you know, the big thing, the national data linkage. And so there was a 3-year application and approval process for the 3, so the 3 years of the grant were basically taken to do that. And this story won't surprise anyone, but we needed to secure approvals from 9 different state, territory and federal departments of health. And what we were basically doing in this case was to link the Australian Orthopaedic Association National Joint Replacement Registry with hospital data, well, a whole range of other data, which I'll tell you as we go through. So 20 different data custodians, 14 ethics submissions, multiple governance applications, 7 data linkage units to realise linkage of 21 data sets. So this total data linkage marathon, this project. And then we had to establish a secure data repository because the project is led by the Joint Replacement Registry. There was a requirement to create a firewall between the identified data held by the registry and the linked data. And then once we had the approvals, there's another 18 months for the actual linkage and data extraction process. And we just waited in multiple queues in multiple different data linkage units for quite some time. And so that gives you a little bit of a timeline that the first ethics approvals in 2016, and it's only now in 2022 that we're finally getting, I mean, it's very exciting, but we're finally getting hospital data from the jurisdictions that have participated. So we've now, many years into the process, got a wonderful data resource, but we've spent all the money on the grant. So we're just going to have to go and apply for more. So what's in the data resource? 21 different data sources. I'll just quickly flick through them. And as I said, the final stage is happening now with hospital data being received from the final couple of jurisdictions. So there's going to be some really great outcomes from this project, so watch this space. But there's already some early work that we've done just using New South Wales linked data, which we got more quickly. And one of the key outcomes of interest following joint replacement is periprosthetic joint infections. So infections around the prosthetic joint, obviously something that highly to be avoided. And the only thing that's actually captured by the National Joint Replacement Registry is where the procedure where there was a revision for periprosthetic joint infection. But other periprosthetic joint infections that don't result in revision are not actually captured in the registry. And there's a great interest in knowing more about how common that adverse outcome is, and and also what are the predictors of it, and how much does it vary between different sites, different surgeons, different forms of procedure. And so just through linking the joint replacement registry with admitted patient data, we could actually have some estimates of how many of these periprosthetic joint infections were not being identified purely through the revision statistic that is captured by the joint replacement registry. And you can see that down the bottom in this figure is what's captured by the registry, very, very low rate of revision for periprosthetic joint infection, around 0.2, 0.3%. But then once we add in the infections that we identified using several different algorithms from the admitted patient data, we get a much, much higher rate of periprosthetic joint infection, depending upon whether we use a really conservative definition or an extended one. We're up around 1.5 or 2%, so 10 times the rate that is actually identified through the registry. So this is a very early result from the project, but there's going to be a lot more and huge amount of interest in outcomes other than revision, which is the main outcome currently captured by the registry. And again, this paper has been accepted by the Bone and Joint Journal, which is a very high impact journal in its field. Again, having the registry in there is what enabled this project to at least achieve impact in an academic sense. It's early days in terms of impact, in terms of improving clinical practice. And then the final one I want to talk about is, again, linking in a quality registry. In this case, it's in vitro fertilization. And this is you will not be able to read this, but again, this is pretty much an extreme data linkage that involves multiple different data sets being linked together. But the one that is particularly novel is ANZARD, which is the Australian New Zealand Assisted Reproductive Database. That's actually where we're actually the data custodians of that in the Centre for Big Data. But what we linked it with was obviously the perinatal data in terms of birth outcomes, but we also linked with both MBS and PBS data in order to identify other forms of fertility treatment that are not captured in the Assisted Reproductive Database. So there are there's medications that are given to stimulate ovulation and so on. They cannot be captured just through ANZARD. We needed the PBS and MBS data to look at those. But you don't need to look at this, it's a published paper, but again, it was very complex. But this project only used New South Wales and ACT, because going through what we went through for joint replacements, it's just not something you can feasibly do all that often, given that it takes 6 years to end up with your data set. And again, now we have this data resource, have started to publish from it. And this is really actually quite a descriptive paper, but the first paper to actually be able to estimate what proportion of births currently are medically assisted, whether that be through assisted reproductive technology or through non-ART, which is basically medications. And what you can see looking at the left-hand panel there is that there's currently around 6.7% of births are the result of medically assisted reproduction. That's been climbing quite steeply over recent years, and that climb is driven by assisted reproductive technology, so IVF, rather than the other forms of fertility treatment. And then the right-hand panel gives a bit of a breakdown of the various forms of medically assisted reproduction. And the one that's most striking there is that the use of the frozen embryo is becoming dominant over other forms of IVF. And this paper, only just published, has received quite a lot of attention because it also provides information about success rates of IVF at various age groups, or of medically assisted reproduction by age group. And this sort of message around the idea that perhaps women are believing that they're going to have higher success rates than they actually may, in terms of what the evidence from this data linkage study shows. But again, even more than that, we actually have gone on to sort of create a tool which is for people who are considering IVF to actually estimate what their chances of success are, which is called Your IVF Success. It was actually funded through the Australian government, through MRFF. Everything in it is actually based on algorithms that are derived from the linked data studies. We're just updating them based on some of the new data that we've got. But basically, it enables you to enter your details about yourself, about your infertility diagnosis, your sperm provider's age, and so on, and then get an estimate of how likely you are to successfully conceive with various numbers of cycles of IVF. And the same website, if you want to go and have a look at it, actually does provide information about comparative success rates by IVF clinic as well. And there's been a sort of overwhelmingly positive response about the availability of this, so people are able to realistically estimate what their chances are. Noting this is a high cost industry that's heavily advertised. I'm sure you've probably seen the ads yourselves. And it's really important that people have strong evidence on which to base these, expensive and also, hugely taxing and costly personally sorts of decisions. And finally, as another example of linking in novel data, and this one's only, very, very much work in progress, is the linkage of data that come from electronic medical records with the routine administrative data. Any of you who've tried to do this will know there's a lot of challenges in this, because at the moment, although starting to emerge, there are not aggregated data sets from across multiple hospitals. Queensland is somewhat ahead of other states in this. In New South Wales, basically there's 7 different Cerner EMR implementations across the state. And really you have to go on an almost hospital by hospital or local health district by local health district approach if you're trying to access these. And they are not data as we understand them when they come out of a Cerner system. They're not nice square tables of data that you get from, out of administrative data. They are really, really messy. There's many, many different tables. They are not designed to come out of the back end in an analyzable form. And so there's a huge amount of data transformation work that has to happen. But we're making progress. We have a project called Cardiac AI, which actually is using Cerner data from 4 different hospitals, public hospitals in New South Wales, a remote monitoring application for people who've been discharged from hospital, and also a software platform that allows entry of data from private hospitals, because in cardiology, a lot of the work is done in private facilities, and we really need to be able to link that in as well as the public data. And then we're linking that to administrative data through the Centre for Health Record Linkage for those longer term outcomes. But I think importantly, for anyone who is considering leaping into using EMR data, there's, as I said, a whole lot of work to actually turn them into something that can be analysed. And in the case of Cardiac AI, we've developed a pipeline that does a range of things, but ends up with data that have been transformed into, some of you will have heard of this, the Odyssey OMOP Common Data Model, which is an international common data model that enables you to, it will enable international comparative research, with these data over time. But one of the important things we found that may be of interest to people is that there is rightly much hesitation about providing research access to electronic medical record data because they contain a lot of identifiers in clinical text. And, you know, these include not only names and addresses of patients, but also names of clinicians, you know, phone numbers, email addresses, a range of things. And the first thing that we had to do before we could get anywhere with this project was actually develop a mechanism for de-identifying the clinical text. And we have a PhD student who basically has worked on this and has now developed an end-to-end software framework that actually allows you to install the software locally, you know, in a local health district, for example, annotate the data. So you have to go through and with, you know, several hundred clinical documents, actually annotate saying this is a name, this is an address, and so on. But then uses that annotated data set to build a machine learning model that they can then automatically remove those personal identifiers going forward. And it's quite a novel thing. There are commercial attempts to do this, but at the moment these all involve uploading your data to a cloud-based system, often in the US, which is just not going to be acceptable for Australian data. So the fact that you can install it and use it locally is a key feature. Okay, next. Finally, integrating novel analytics, and I won't spend as long on this, but I think, as I mentioned earlier, there's a huge amount of interest in machine learning and AI approaches. But there's a huge gap in the way we approach questions compared to a traditional epidemiological approach and the typical machine learning approach, which is very much based on just trying to achieve the best model fit and the best prediction, and traditionally has been less interested in trying to explain those sorts of predictions. So I think there's a real opportunity for linked data researchers to start to become familiar with these methods, but to try to integrate them into approaches that do allow explainability and will drive potential implementation. Because at the moment, there's just this, it's one of the biggest chasms you can imagine between developing lovely algorithms that predict things and actually using them in practical ways to either drive population health planning or drive clinical care. And so one piece of work we've done is with our New Zealand colleagues using national administrative data sets, which are a lot better than the ones we've got in Australia, which I'll say a bit more about. And then combining a traditional survival analysis, which you use for risk prediction, with a deep learning approach, and then comparing, the two approaches and what they spit out. I won't go into this in a lot of detail, but this is just a lovely diagram that sort of represents the approach that was taken, and that we did use some pre-specified predictors, and then we also identified other predictors, and these are quite detailed data that contained medication histories and histories of primary care use, and use what's called an attention mechanism. I just raise that because it's important. And in the context of machine learning, the attention mechanism allows you to identify which elements of the data the neural network paid attention to when coming up with its predictions, i.e. which things were particularly influential. And so being able to use those attention mechanisms to then identify, okay, these were the things that drove prediction, is an approach to explainability. Just some of the results from this very quickly. We found that the deep learning models did improve both calibration and discrimination, not a huge amount, but somewhat, over traditional Cox proportional hazards. But in particular, they perform better in population subgroups, such as people of lower socioeconomic status and Maori men and women. But overall, in basically all subpopulations, deep learning did perform slightly better than the traditional Cox proportional hazards. And because we'd used the attention mechanism, we were able to produce something which are equivalent to local hazard ratios. So they're sort of things that epidemiologists understand, to look at what were the factors that were most influential in driving cardiovascular risk. And I won't read all of these out, but you can see that they sort of make sense. They have face validity in terms of they are the known cardiovascular risk factors, such as having diabetes, having atrial fibrillation, taking cardiovascular related medications, tobacco use, and so on. So, I encourage others to try to draw together the worlds of epidemiology and the worlds of machine learning to come up with these much more explainable sort of approaches that integrate the two. And finally, I'm just going to talk a little bit about data, because that project used New Zealand data. I think many of you will know that New Zealand has the Integrated Data Infrastructure, or IDI, which is just the envy of me, and I think the envy of most Australians, that they have managed to put this together. You can see it brings together many forms of data, that are considered non-health or from other sectors like education and training, justice, and so on. But this box here on the right just shows the health data that they have. And you can see that, it's really, really, much more detailed, and it's available for the entire population compared to what is available for us. And in particular, things like laboratory claims, we don't, they're really hard to access in Australia. Anyway, it's been an aspiration of many of us to try to have something like this that we can use in Australia. And my final slide is just about the LINDA project, which some of you, I think probably, I don't know who's on the call, but I know Merrin is certainly, very involved in this project, and there are a large number of partner organisations, academic partner organisations, and the Australian Institute of Health and Welfare is, a key partner in it. And it's funded through the Australian Research Data Commons. And the underlying idea behind it is basically to enable researchers to access in a much more streamlined way a national linked data set for Australia. So we don't have to go through that incredibly painful process that we went through with the Joint Replacement Registry, or we don't need to be limited to only one state or territory only, as we were with the IVF data. Even though we had national data with regards to IVF, linking that with national data for perinatal data and so on was just not going to be feasible within the funds or time that we had. And so the LINDA project is going along. There's a lot of activity in the area with the new data sharing legislation, a number of initiatives that the AHW are working on, including NICI, which many of you will be familiar with, and also a newer initiative called ANDI, which is again about sort of national data linkage. But the focus really of LINDA is researcher access to the data, because many of the other initiatives, the focus is very much on government access and government use. And there's not an opposition to researcher access, but it's not the primary focus of the work that's currently happening. And it may, it's shaping up, I think, that LINDA, probably its end product will be an ability to access the NICI data, or a version or twin of the NICI data for researchers. And that box there on the left, the data sets shown in bold are the ones that are part of NICI. So, I look at the ones shown there in bold, and from my point of view, I could probably, use those. That's enough to service the rest of my research career, actually having all of those linked together at the national level. But there's a hope that further ones will be linked. And recently, as part of LINDA, we've conducted a research survey, which I think hopefully many people on this call participated in. And one thing that's obviously really important to researchers is not just having the routine data, but also having the ability to link in some of those other data sets, the things that I demonstrated, like registries, cohort studies, clinical trials, which I haven't talked about. And that again is something that is really not on the agenda for government agencies. They don't have that interest. But as a researcher, I think that is totally critical, because that is the thing that allows us to do projects that will have a a high academic input in terms of getting into clinical journals, but also are much more likely to result in things that can be translated because they contain that detail that allows you to risk adjust to produce reliable real world evidence that can reliably be used to drive changes in, for example, clinical practice. So anyway, that's Linda. Watch this space, and I think the signs are really positive that hopefully in around 2 years there will be a much easier route for all of us to try to access linked data, but also to potentially speed up bespoke linkages of clinical registries or other research data that we hold to that administrative data spine. So I think I've rabbited on for long enough, and I'll say thank you and welcome any questions.
Okay, well, look, thank you, Louisa. That's been a fantastic presentation. And we do have a couple of questions. I'm a little bit conscious of the time, so we probably will, and I think we can work through them relatively quickly, and I'll just go through them in the order that they've come in. The first one, I think, is a pretty straightforward one, which was a question about how you can confirm that linkage was accurate in the Health Direct case when some callers were anonymous.
Well, basically, I don't have that slide in front of me, but yes, they're one of those exclusions. That's how we went down from 1.4 million, whatever it was, down to just over 1 million. Yeah, so yes. If they couldn't be linked, obviously they had to be excluded. Yeah.
And then another question, this one from Alex Lee. What sort of techniques are being used to link the various data sets?
Yeah, so probably most of the examples I showed you use probabilistic linkage that is done by the data linkage units. They use various different software, but it is all probabilistic where they set cut points, and then in some cases do clerical review of those that fall outside those, in other cases don't. But I did forget to mention that linkage of the Australasian vascular audit that I presented, it was actually what we call a DIY linkage. So we didn't actually go through the Centre for Health Record linkage or a data linkage unit because it was a clinical registry for quite specific, vascular surgical procedures. And we had the hospital identifiers and the dates and the ages and the sexes of the patients. We actually had enough information to perform a deterministic linkage. And I think it's probably quite important that researchers don't discount the fact that you can actually do a deterministic linkage if you have sufficient information. Clearly, you need to get ethics approval to do it, which we did, but it cut out that whole step of having to involve, and the cost of having to involve a record linkage unit.
Okay, thanks, Louisa. And the next one is perhaps a bit related also from Alex Lee. What do you see as some of the best ways to speed up the data approval process when developing linked data resources?
Well, I think it is having these already developed assets, things like NICE, like what Linda is aiming for, where linkage has already been done, rather than linkage being approached on a project by project sort of basis. That's probably the number one, but there's clearly a lot that needs to be done in the governance area because there's just great inconsistency between the different states and territories, in particular in the Commonwealth and the linkage units. So, I think the idea of having some large-scale linked data assets that are already linked, that are updated on a regular basis, that are curated so they're in a research-ready form and available with governance, but a lot lighter touch that probably does not involve full ethics approval for every project. And one thing that particularly is a bugbear of mine is that many ethics committees require you to justify every single variable that you want to use, which is really, really a waste of time, and is also, if you're starting to move into machine learning sorts of approaches, you really want to have as much data as you can possibly get. It's again one of those things where there's possibly a clash between new analytics and the way we traditionally think about, reducing the amount of data that people are given.
Perhaps a sort of supplementary question from me is how useful do you think it would be if we could routinely link some of those big national clinical registers?
Really useful. Yeah, because as I said, you cannot get published in clinical journals if all you've got is admitted patient data and MBS and PBS, because they just do not contain the detailed patient information and procedure or disease information that's needed.
So sort of a routine annual linkage of those.
Yeah, and certainly that's what the joint replacement registry wants to achieve that. Yeah.
Yes. Okay, and now just another question. I'm distilling the essence of this, which I think is, do you think that the delays in receiving linked data are improving? Wondering on your thoughts about how to improve the generation of timely real-world evidence.
I don't think they're improving. I don't think they've improved over the past 10 years. It still takes, well, I showed you that joint replacement project. It's only just happened that we've received the data. So we really do need to take a different approach, which I think is having these large assets that are curated and linked centrally, and then a much more streamlined approach. I'm afraid states and territories are going to have to sort of, you know, put away some of the thing, you know, what is it all about? I don't quite understand. I think a lot of it is they don't want to be benchmarked against one another. But I think COVID has actually changed the way people view things, and many of the problems that we had during COVID related to inability to share data between jurisdictions, lack of national data. And I think there is much more will in terms of state and territory and federal governments to deal with this. But that, as I said, is largely driven by what governments need. And of course they need it, but we need to make sure the researcher voice is in there. So whatever arrangements are put in place don't sort of make researcher access even more difficult than it currently is.
Yes, well, look, thanks for that. I think we've probably got time for one more quick question, which was around, are there any plans to include GP data in the Linda database?
Other than MBS, no. The UNSW does have a sort of a program of work around general practice EMR, but as far as I know, there's no plan at this stage. And it's a little bit like, although probably not quite as bad as the hospital EMR situation, where you've got multiple different software vendors that have to be worked with. Obviously, there's My Health Record, which is, you know, to have time to talk about, but there is a framework for secondary use of My Health Record, and it actually captures quite a lot of general practice-based information. That's gone very quiet lately, but I think probably post-election that, you know, there may be some movement in the secondary access to My Health Record space as well.
Okay, well, look, I'm conscious of the time, so I think we'll finish the questions there. And just to say, Louisa, on behalf of today's webinar attendees, thank you very much for an inspiring and thought-provoking presentation. And thanks to everyone for the questions, and to Louisa for her responses, because I think that was also really interesting. So in finishing, I'd just like to mention that PHRN's next Linkage Luminaries webinar is with Professor Leon Flicker, who's the Professor of Geriatric Medicine at the University of Western Australia, and that's on the 30th of June, forthcoming, not too far away. So that concludes today's presentation. Thanks everyone, and goodbye.
Thanks, Baron. Bye.